So the theme for the weekend is the future of humanity, and this will be one of the talks later in the evening, later in the weekend. That's pretty out there. So
It's pretty what, out there?
out there.
Okay.
And so this talk is about from life before Earth to sort of the transcension hypothesis, which is kind of life after Earth, and going through sort of what happened before Earth and how things evolved here, and then where they will continue to evolve. And so many people have seen sort of this evolutionary path up to about here, and then what happens beyond sort of regular human situation. And so starting way back before the Big Bang, there's, for the Big Bang to have occurred, you need space and you need time. And both space and time are dependent on an observer. So it's space relative to where the observer is, if that's you, and time relative to the observer. So both space and time could be argued to need a consciousness observing them. And so that's a whole discussion by itself. But from essentially the Big Bang to the present, things more or less started in the realm of physics, then became chemistry, and then biology. And so this is sort of time across 13 billion years. And so the Big Bang occurred at a space and time that was 13.7 billion years away from here, and in time at least, and in space it's a different kind of way to explain it, but there's some question about, well, did the Big Bang occur and that kind of thing, and it can be argued that you can see the microwave radiation. You can literally see the Big Bang if you have a good enough telescope. So even if there's other theories about why it happened or how it happened, there's really strong evidence that it did happen and where and when. And so where we are in the end is here's us in what's called a supercluster, which is in this part of the universe, and all these are galaxies mostly. So there's a lot of stuff that is not here, and one of the questions is, why isn't there intelligent life anywhere else? And it just means we haven't seen it, but there's a very high probability that there's more of these somewhere. How did life start, and where did life start? And so this is an important graph in that this was the origin of the Earth 4.5 billion years ago, and these are the increasing complexity of species on Earth over the last 4 billion years. And this is a logarithmic graph, so on a regular graph that would be going up super exponentially. So things are getting more and more complicated, more DNA, more genes, more molecules, more complexity, multicellular, language, culture, all these things going up this way. And so if you just make a simple exponential graph of complexity over billions of years, so here's 10 billion years near the Big Bang, and there's where we are today. The complexity of life goes up exponentially, and so if you just flatten that out on an exponential graph, here's today's complexity. It was less a billion years ago, a lot less 4 billion years ago, but not zero. So life was already complex before this planet even formed. And so how did life get so complex so fast? Did something really different happen there? Or did life start before Earth started? And so this is a real sort of common sense, simple way to look at it. But if you just draw that, if this is, a 1,000 genes there, and people have 23,000 genes, when were there no genes? And when was it zero? And so that actually projects all the way back to 9 or 10 billion years ago, long before Earth started, and maybe not at the origin of the Big Bang, but certainly in that realm, given the errors that could be there. And so here's where we are in our little galaxy. So this is us, and this yellow triangle is what the Hubble telescope can see, which is just a little bit further along than we are going around our orbit of the galaxy. And in the center of our galaxy, in most galaxies, is a black hole, and that's what we orbit around. And so there's a lot of places where material, chemistry, other planets, other sorts of things can be going on just close by in our own galaxy. And then right around the Earth is something called the Oort cloud, which are asteroids and planetoids and small things that are quite far away from Earth, but they're much closer than other solar systems. And so here's us, and then there's the asteroid belt, the Kuiper belt, and the Oort cloud. And so a lot of things can be happening in those places where components of life can be evolving. And so indeed, in the last few years, they've found in space sugars, amino acids, all the amino acids, all the bases of DNA and RNA, phospholipids, which makes membranes. So the essential ingredients to construct life, they've found them in space, far from Earth, some free floating in space clouds, some on asteroids, and so forth. And so all the ingredients are there, not here. And some of those asteroids sometimes hit Earth and can make a big hole, or bigger where the dinosaurs all died, or small size, but these asteroids are coming through that soup, and in some cases maybe carrying molecules that have been discovered out in the soup and are essential to life here. And so all the ingredients for the recipe of life are there. They're arriving on asteroids, and you can bake them when they get here into life. And then by natural selection, some of them disappear and go extinct, and others procreate. And so thus we're, here, pieces of life arriving where the ingredients are on the Earth, and the conditions on Earth were ripe enough for the seeds of those ingredients to form into life the way we describe it with chemistry. And then it's evolved and gotten more complex since then. And so these sort of first parts of where the chemistry of life came from, where it started, how it started, when, that kind of thing, is sort of the story so far. And another leap in the complexity of life, where there may have been biochemistry happening in some sort of replicating way, but to make that more efficient, the code of those ingredients that say this is how you make a protein got encoded into RNA and DNA and ways of storing the software that describes the recipe of life, which created more complex biological life, which is code that turns into chemistry. But it's an abstraction. It's kind of like analog to digital, where the code can be replicated more efficiently with fewer errors. And that allows biological life to get exponentially more complex, which is this sort of concept of exponentials under natural selection. And so other exponentials that or familiar for some people is the Moore's law is the like how complex chips get over time, and they get approximately twice as good every year and a half, and have been for over 100 years. So it's not having to do with chips because transistors did the same, relays did the same, and so on, and even punch cards that were all mechanical. So different ways of doing digital calculations have been getting exponentially more complex and better, faster and cheaper. Not just physical electronics, but this is the performance of wireless over 100 years. So at the time the Titanic sank, they didn't have cell phones, they just had Morse code, which was a few bits per second. And over time, it's gotten faster and faster to now we have, up to a gigabit per second wireless. But it's on a very straight line on an exponential graph. So this, it goes from 1 to 100 to 1,000 to hundreds of millions or trillions. And so it's that kind of scale is possible in the complexity of biology and information and communication and semiconductors and so forth. And so here's a graph of brain size to body size on a double exponential chart. And so intelligence is essentially going up this way. And if the body is big and the head is small, the intelligence is not as high as if the head is big and the body is small. And so this is sort of a way you can see there's different niches of big brains, small bodies that are more intelligent but not as big as some of the other choices. And so essentially that's humans, which are on that chart, but then up and coming is digital. So that's improving exponentially faster than the capacity of human intellect. And we're maybe about here, but we're soon, in the next dozen years, going to cross over where the AIs will be smarter than the smartest people. And there's all kinds of debate what will happen there, but for sure this time is going to be less predictable, more chaotic, and maybe disturbing to people and the way that they view life, because they won't necessarily be the alpha top intelligence. And so these are the sort of exponential epochs of evolution, where first we were talking about physics and chemistry, then coded biochemistry, DNA, and then information in neural patterns, which is like memory and language and things like that. And then that evolves into hybrid software hardware designs, which are like computers and phones and things of that nature. And then the next merger epoch will be into this transition from biology alone, technology alone, to hybrid biology and technology intelligence. So hybrid internet human intelligence. And then when the next epoch beyond that is sort of when that becomes conscious enough, and then it goes woke. So when the universe as a whole is not only intelligent, but becomes conscious. And so that's where this gets more exotic. So biology's technology is sort of still in the chemistry realm, of going from cellular to multicellular. Eyes were invented about 500 million years ago, and at the same time as when brains were invented, or became important because of two things. One is eyes is information that's processed in the brain, other senses as well. And secondly is the brain. The brain allows you to move. So as soon as the creatures go from what chemistry is flowing by to I can see and I can decide to move, That's a big advance, and that was only 500 million years ago. And then tools, which is I can figure out that how to make a tool that will speed up my thinking. And so the tools are essentially technology, and the evolution is happening at the same time. So along about the invention of tools, people started to improve the tools and change society and so forth. But life became complex. That's no longer a person. A person carrying one of those is a person. Because if they don't have a phone, they're not part of society. And then society became more important with the invention of grandmothers, which is sort of like a memory chip. Then fire, being able to control fire, cook food, more nutritious food, smarter people. And electricity, which is essentially controlled fire and is essentially the internet is just smart electricity. And so that's allowed faster, better communications and memory between people. And people have gotten smarter about using the internet to become a society. But the internet is continuing to get smarter at an exponential pace, faster than people are getting smarter. And the AIs are the internet getting smarter and quickly. And so our brain is kind of limited by the size of a woman's pelvis, and that it can't get much bigger with natural birth. And so the brain can't get a lot smarter given the limitations of biochemistry and being able to be born. And so some people are switching to C-sections and maybe will breed with others that make heads bigger than could even be born in a biological way. So there'll be some improvement in the brains, but the improvement in the phone and the internet is so much faster than the improvement in the biology that the intelligence is shifting from the biology into electronic. And already there's concepts of sort of like what we know and what we don't know. And this is a picture of the firmament, which is a religious concept of what's in the realm of man and the realm of God. And that's been cooked up, but that's being expanded because of a number of reasons, but the internet mainly and virtual realities, where in the virtual reality in the metaverse and so forth, the laws of physics are no longer a constraint. Like you can design experiences that couldn't happen in the regular world, but the person can still experience them. And so that's sort of a religious experience in that there's the firmament, there's the earth and the underworld and the realm of God. And these things are becoming more accessible because of the technology. And one of the interfaces between the brain and these windows into the electronic metaverse is VR. The VR is really only looking at the eyes and maybe posture. And so more advanced versions of VR are not only your eyes, but your ears and your voice and your breath and your body and so forth. So essentially a immersive sensor system that connects you to the internet going out, but it connects the internet coming in, where if it can massage you or whatever strikes your fancy. And so the transcension hypothesis was developed by a guy named John Smart, who was trying to answer why. So Fermi's paradox, Fermi was a physicist, and he has a paradox, is that if it's possible to make life in chemistry and life can become intelligent here, why is it we don't see it on the moon or on some nearby planet or star or something? We don't see any evidence of it. And so the paradox is, if it's so easy, why don't we see it? And so that's something that like the pessimistic answer to that is that there's something about intelligence where when you develop enough that you can kill and kill a population and kill a planet, that the history of the universe is intelligent civilizations go extinct. They kill themselves. And so that may be a pessimistic reason why we don't see any other intelligent life anywhere nearby. And an alternate optimistic hypothesis is that called the transcension hypothesis is in this exponential improvement that the technology is getting faster, cheaper, smaller, and quieter. And so you don't have big TV broadcasting and big radios and all that kind of stuff. You have much more efficient, much more compact, like cell phones and such. And those can communicate where it's very difficult for somebody even standing nearby to detect them. And so even though like a more AI internet kind of society will be more complex and more intricate and more experiences that are mostly virtual, somebody from another planet wouldn't even be able to tell they're there. And so the reason that we don't see any other civilizations is the ones that don't do that don't survive. And so either they kill themselves or they broadcast themselves so much that somebody else might come eat them, or they become more quiet and more stealth, sort of like bats and owls and worms and whatnot, that are undetectable because it's just a natural evolution of the complexity of technology and intelligence. And so that's how you get from physical to transcendence into virtual. Okay.
Wow.
That was awesome.
I worship the machine god.
You too.
What do you think about in the Darth, I mean, it's specific, but like the Darth Vader versus like Matrix plugins?
I don't understand.
Like there's the Darth Vader cover
Outfit.
your suit, cover your
Yeah.
senses, and then something like the Matrix, which would be
Oh, well, that's sort of just turning it inside out. It's basically connecting the input and output of the brain to the external world instead of just your body. It's sort of like a tool, like you can make an axe that allows you to kill somebody at a distance. And so being, by having the axe, so if you're in a virtual suit, like you get more leverage in the tool. You have more interface to the tool, and so it acts as a bad example. But basically, it becomes harder for you to distinguish the real world from the virtual world because more of your senses are involved.
But like if you were in the Matrix type thing, could something be downloaded?
Well, and so if you say for safety we won't penetrate the skin, and you wear a Darth Vader outfit, but you could say, well, we can, instead of tricking the eye, you just put electrodes right in the optic nerve, and you put the sensations there, and that way it can all be under the skin.
I think what she's saying is like, so you're in the world, can you get downloads that then you take out of the world? So you essentially learn how to play the piano in 30 minutes, but while you're in this virtual reality, you're actually like spending 10 years playing piano?
Well, the answer to that is complex, but because nobody knows all the details of how learning how to play a piano work. But the important thing to take note of is that you can get a download of things that can't even exist in the world. In like how well you play the instrument in VR, it doesn't even matter how you do it in the real world because it doesn't exist. It can't exist. So there's things like that are going to take a long time to figure out, but it's not a simple answer to that kind of problem.
So are you saying that each civilization has like 3 options of like there's an evolution or and basically what you're saying is we're heading fast towards an evolution of some
Well,
kind.
evidence is based on the Fermi hypothesis or paradox, is that the evolutions or the civilizations, intelligent civilizations, go extinct, or they hide real well. And so a pessimist would say, well, they'll kill themselves, or somebody eats them. And optimists would say, well, no, they just direct their attention into electronic form, and they're invisible. And that's assuming it's like the electronics that are easily conceived of now. But if any of you saw the movie Contact, that in that movie the aliens don't look, they don't even need a planet. They're able to travel through time and space without a physical body, and they set up a system that allows a human to get in their system, to go visit with them, and they're not explaining how all that works, but they even say, well, we don't know how this works, somebody left it from billions of years ago. And the intelligence, the alien intelligence, is not in a physical body, they're not on a planet, they're everywhere and invisible. But they can make themselves visible for the interaction. But it's sort of like if we were trying to communicate with the hornet's nest, well, how would we even do that? Or,
Yeah.
you know.
Wow. Cool.
What was
Alright.
the point you were making about
Last
the
question. Go, Alan.
What was the point you were making about the grandmother? I didn't follow that.
That's when our biochemistry, like in most species, their biochemistry kind of runs the system, and they don't have culture and ideas that they pass on to their progeny, you know. And so, in most of them, they do that through the life of the female, like the mother taking care of the puppies and so on. But they don't have a culture that transcends breeding lifespan. It's only a couple species. There's sort of an innovation in evolution of like killer whales and humans. That in those two species, the breeding females live much longer than their breeding capability. So they have grandmothers, where most species don't have grandmothers. The breeding capability of the female dies with the
Like a salmon or something.
yeah, and so that information that is transferred between individuals in a group from the grandmother is ideas that go through language or writing or that kind of thing that allow for more intelligence because it's better memory. So it's community memory, basically.
Community memory, yeah.
Thanks, Reese.
Hey, Reese.
Incredible.